We're going to use the percent by mass to get the empirical formula, which is the reduced form of the compound, and we're going to use the empirical formula to get the molecular formula, which is the actual formula for a compound. Let's look at some examples. We have a compound that contains nitrogen and oxygen. What is the empirical formula? Well, I'm going to assume 100 grams. So 25.9% nitrogen would give me 25.9 grams of nitrogen. 74.1% oxygen, 74.1 grams of oxygen. We're going to take grams, divide by the molar mass from the periodic table to give me moles. 1.85 moles of nitrogen. Keep 2 places after the decimal when you divide. For oxygen, divide by 16 to get me moles. So 4.63 moles. Now I want the empirical formula. I need whole numbers. In order to get whole numbers, I'm going to divide by the smallest number of moles, which is 1.85. It's going to give me 1 there. 4.63 divided by 1.85 comes out to about 2.5, 2 1/2. That's not a whole number. You can't round it. But I can multiply by 2 to give me whole numbers, and that's what I'm looking for. So my empirical formula in this case, the reduced form of the compound, is N2O5. Let's look at this example. There are 3 elements present. Take those percentages, convert them to grams. And then we're going to take grams and convert to moles. So for carbon, divide by 12. For hydrogen, divide by 1. And for nitrogen, divide by 14. So we have 5.18 moles of carbon, 13.8 moles of hydrogen, and 1.72 moles of nitrogen. Want whole numbers? Divide by the smallest, 1.72. For carbon, that comes out to 3.01. That's close enough to 3 that we can round. For hydrogen, comes out to 8.02. Close enough to 8 that we can round. For nitrogen, it's 1. So the empirical formula, C3H8N. We're going to use the empirical formula to get the molecular formula, the actual formula for the compound. Sometimes they're the same, sometimes they're not. In this example, I'm given the empirical formula. The first thing I want to do is find the mass of this compound from the periodic table. So carbon is 12, plus 4 hydrogen is 4, plus nitrogen is 14. Molar mass from the periodic table is 30. I'm told in the problem the mass is 60 for the compound. So I'm going to divide 60 divided by 30. 2. The molecular formula is 2 times the empirical, which is C2H8N2. That is the actual formula for the compound. Okay, now we'll put both of those previous 2 examples into one problem here. What is the molecular formula of a compound consisting of potassium, carbon, and oxygen? So for potassium, 56.6 grams. Convert to moles, 39.1 grams per mole. For carbon, 8.7 grams. Divide by 12 grams per mole. For oxygen, 34.7 grams. Divide by 16 grams per mole. So the number of moles, 1.45 for potassium, 0.73 for carbon, 2.17 for oxygen. Divide by the smallest number of moles, 0.73. Hopefully, this will give me whole numbers. For potassium, that's close enough to 2 that we can round. For carbon, that's 1. And for oxygen, 2.97, close enough to 3 that we can round. So the empirical formula we have just found, K2CO3. Once I find the empirical, I need to find the mass of this formula right here from the periodic table. So I add up 2 potassium plus 1 carbon plus 3 oxygen. When I add those together, I get 138.2 grams per mole from the periodic table. In the problem, I'm told that the molar mass is 138.2 for the compound. So obviously, when I divide what I'm told by what I got from the empirical, I get 1. So that means the molecular formula is the same as the empirical, which can happen, K2CO3.